Have you ever wondered what's really going on inside the minds of those math geniuses? You know, the ones who can solve these ridiculously complex problems in just a few minutes? Well, today we're going to peel back the curtain on the high-stakes world of competitive math. And I'll tell you right now, this isn't just about crunching numbers. It's all about strategy.
Okay, so let's put this into perspective. Think about the American Mathematics Competition, the AMC8. You've got middle schoolers, 40 minutes on the clock, and 25 problems to solve. That's less than 90 seconds a question. And believe me, these aren't your standard homework problems. They are specifically designed to be tricky, complex, and, well, kind of baffling. So what is the secret? How do they do it?
Here's the thing. The answer isn't a faster calculator or some kind of photographic memory. The real secret is a completely different way of seeing the problem. It's about using a master blueprint of mental models, these secret strategies that just slice right through the complexity to find a simple, elegant solution. And today, we are unlocking that very blueprint.
Our guide for this journey is a document we're calling Camille's Cheat Sheet. And this is real. It's an actual digital vault of notes and strategies put together for a top math competitor. Now, this is not just a list of formulas. No way. It's a playbook of powerful ideas, a little glimpse in how to think like a champion, and lucky for us, we've got exclusive access.
So, our first secret is a really beautiful one. I call it the cycle. This is the key to cracking problems that seem impossibly large, the kind of problems that are designed to make you just give up. It's all about finding a simple, repeating pattern that's hiding right there in plain sight.
So check this out. Here is a classic competition problem that uses this exact secret. What is the last digit of 7 raised to the power of 2024? I mean, your calculator would just give you an error message. A supercomputer would probably overheat. But a competitor, they solve it in seconds. How? Well, they don't calculate the number. They hunt for the pattern.
All right, let's track this pattern together. We're going to start super simple. 7 to the power of 1 is, well, it's just 7. So the very first last digit in our sequence is a 7. Easy enough, right? Let's keep this going. Now for 7 squared, that's 49. But here's the crucial insight, the big idea. We are going to completely ignore the 4. We only care about that last digit. So the second number in our pattern is a 9. So far we have 7, then 9.
What about 7 cubed? Now, do we need to calculate 49 times 7? No way. We just take our last digit, the 9, and multiply that by 7. So 9 times 7 is 63. And again, we only care about the final digit, so our third number is 3. You see the shortcut? Our pattern is now 7, 9, 3. Are you starting to feel it?
Okay, let's go one more step. 7 to the 4th. We take our last number, 3, multiply by 7. That gets us 21. So the last digit is 1. Now look, we have a full sequence, 7, 9, 3, 1. And what happens if we multiply that last digit, 1, by 7 again? We get 7. We are right back where we started. That's it. That is the secret. It's a 4-step cycle that just goes on and on and on forever.
So the whole strategy boils down to this simple algorithm. The cycle has 4 steps. So we take that monster exponent, 2024, and we divide it by our cycle length, which is 4. Now, it just so happens that 2024 divides perfectly by 4. It leaves a remainder of 0. And here's the key. In cycle math, a remainder of 0 just means you've landed perfectly on the last number of the cycle.
And just like that, there's our answer. The fourth and final number in our repeating cycle is 1. So the last digit of 7 to the power of 2024 is 1. No supercomputer needed, just a clever mind that knew to look for the pattern.
All right, ready for secret number 2? Let's move on. This one is called the scale, and it's a concept that constantly messes with our intuition. Because when you're talking about geometry, doubling the size of something does way more than just, well, double it.
Here's the core idea, the thing you gotta remember. If you scale up an object's side length by some factor, let's just call it k, its surface area doesn't grow by k, nope, it grows by k squared, and its volume, that absolutely explodes by k cubed. You know, our brains are kind of wired to think in straight lines, but geometry grows exponentially.
This chart makes it just crystal clear. Let's say we double the dimensions, so our k is 2. The length? Well, that doubles, sure. But the surface area quadruples. It grows by 4 times. And the volume? It grows by a staggering factor of 8.
This isn't just some abstract rule for a math test. It's a fundamental law of the universe that shapes everything from how buildings are made to how animals evolve. I absolutely love this quote because it makes the whole concept so real, so instantly understandable. Think about it. You double the size of a building's blueprint. You're going to need 4 times the paint to cover its walls and a massive 8 times the concrete to fill up its volume. Understanding this simple principle is the difference between success and, catastrophic failure. And that brings us to our third and final secret, the trap. You see, the best competition problems, they're designed like magic tricks. They use logical misdirection to fool your gut instinct. The key isn't to be smarter than the trick, but to know how it works, to be able to spot the sleight of hand.
All right, here's a classic trap. So let's say a stock you own goes up 20% one day. Awesome. But the next day, it drops 20%. So, are you back to even? Right now, every single part of your brain is probably screaming yes, but that's the misdirection. That's the trap.
The answer is a simple, and for a lot of people, a really surprising no. You are actually worse off than when you started. Let's walk through exactly why this little magic trick works.
Okay, let's break it down with a simple $100 item. A 20% increase takes you to $120. Easy peasy. But now, and this is the key, when the price drops 20%, you're calculating 20% of the new higher price of $120. Well, 20% of $120 is $24. So you subtract that $24 from $120 and you end up at $96. You've actually lost $4.
So, the crucial point is this. The trap works because the baseline for that second calculation shifted. The up 20% was based on $100, but the down 20% was based on $120. Once you see that hidden shift, the magic trick is totally revealed.
So we've uncovered the cycle, the scale, and the trap. But listen, these are not just clever tricks for a math competition. They are fundamental upgrades for your mental toolkit. They are new ways of looking at problems no matter what field you're in.
So here's what you should take away. First, always look for the cycle. In any complex system, from the stock market to your daily habits, there are often hidden loops that can simplify everything. Second, understand the scale. Remember that small changes can have explosive, non-linear effects. And finally, anticipate the trap. Train yourself to question that first gut instinct and search for the hidden shift in the logic.
And that leaves us with a final thought. We saw how a seemingly impossible math problem was totally defeated just by finding a simple, hidden pattern. So I'll leave you with this question. What impossible problem in your work, or maybe even in your life, is just a complex system waiting for you to find its simple, elegant cycle?